Now we're going to look at identify and graph polar equations by converting to rectangular. So we're going from polar to rectangular. So we have this first one. It says convert polar equation r equals 2 secant theta to a rectangular equation and draw its corresponding graph. Okay, so first of all, we don't have a relationship for secant. So we have r equals 2 secant theta, but that could be written as 2 over cosine theta. So we do have something with cosine theta. Now, if we have r equals 2 over cosine theta, I can multiply both sides by cosine theta, and then these thetas divide out. We end up with r cosine theta equals 2. But what was r cosine theta? That's just x. So x equals 2. And what kind of graph is that? Well, that's a vertical line. Let me scroll this up here. That's this line like that. So over here would come to the 2 mark. That's here. It would be a vertical line through there. Okay. And just for fun, I have Desmos up here still, so I'm going to drag this over and let's look at it. Okay, so if I graph x equals 2, look at that vertical line. We're not surprised there. That's what it would look like. But then we look at r equals 2 secant. I save this for this live. There, look at that, same thing. And again, I'll toggle between them, and the scaling's the same, so they're overlapped. It's really cool. Okay, moving on to the next one. It says rewrite the polar equation 3 over 1 minus 2 cosine theta as our Cartesian equation. So let's have some fun with this. Okay, so first things first, I have this r equals 3 over 1 minus 2 cosine theta. It'd be very helpful to get rid of this out of the denominator. So I'm going to multiply both sides by 1 minus 2 cosine theta. 1 minus 2 cosine theta. So that these divide out. And now if I distribute, I'd have r, let me just do not distribute yet, r times 1 minus 2 cosine theta equals 3. Now, recall that cosine theta is defined as x over r. So I can replace the cosine theta with an x over r. So this becomes r times 1 minus 2 times x over r equals 3. And I'm going to distribute through, so r minus 2 times r times x over r equals 3. And these r's here will divide out. So we have r minus 2x equals 3. Now, if I were to add 2x to both sides, and I have a reason for this, you'll see in a moment, r equals 2x plus 3. Now, what is r? We know we have the relationship r squared is x squared plus y squared. So if we were to square both sides, we were to square this side and this side, we have r squared equals 2x plus 3 squared. And r squared is x squared plus y squared. Okay, so equals this 2x plus 3 squared. Now, if I'm solving for y, that's how we normally have these equations. Subtract the x squared. Y squared equals 2x plus 3 quantity squared minus x squared. And take the square root. Y would be plus or minus the square root of 2x plus 3 squared minus x squared. There you go. And this would be the equation of a hyperbola. Okay, I can hear you asking, so let's go ahead and bring the graph back over, and we'll look at these graphs. Okay, the first one was r equals 3 divided by 1 minus 2 cosine theta. There's that. Now let's go to the other one, and that one came out to be y equals, oh, problem with this, it's only going to be able to do half of it, I believe. Let me try this. What if we just went with this? Y squared equals 2x plus 3, nope, 2x plus 3. I'm going to square that, and then I'm going to subtract x squared. Boy, to see all the changes happen as I'm typing is pretty crazy. So let's toggle between them. Oh, 3. Boom. There. Now they line up exactly the same. I was going to say, uh-oh, we have a mistake. Okay, that's fun. Let's look at our last example. Rewrite the polar equation r equals sine 2 theta in Cartesian form. So for this one, we need to break this down a little bit, so use some of the rules we have. So r equals sine of 2 theta. So r equals 2 sine theta cosine theta. Now recall that sine theta is y over r and cosine theta is x over r. So this is r equals 2 times y over r times x over r. So we have r equals 2xy over r squared. Now we can multiply both sides by r squared. R cubed equals 2xy. Now recall that x squared plus y squared equals r squared. And let's just play with the powers for a moment. So what we have is an r cubed. So would it be true that r squared to the 3 halves equals r cubed? Couldn't we say that? So this could become, did my pencil dust die? There we go. That becomes r squared to the 3 halves equals 2xy. And what was r squared? Well, that was x squared plus y squared. That's to the 3 halves equals 2xy. So it doesn't clean up much better than that, but you could, I guess, take both sides of the 2/3 power. And so if you had x squared plus y squared to the 3 halves to the 2/3 equals 2xy to the 2/3. So you could have x squared plus y squared equals 2xy to the 2/3. I mean, it's nothing great, but this works here and this works here. Okay, and that's it for this video.